Hey guys, welcome back to another video. I'm Tarish, and in today's video we're going to be continuing our topic about kinematics. So we've already discussed about what instantaneous velocity, and what instantaneous acceleration means, and instantaneous speed. Actually, we haven't spoken about this yet, but I just gave a very brief introduction about this. So let's talk about this for a second. So what do we know about instantaneous acceleration? Instantaneous acceleration just means at that exact moment what is my speed, which is nothing but dx by dt, which is pretty much just differentiation. You can write v is equal to dx by dt, so that means you're differentiating your displacement with respect of time and you get velocity. Similarly, if we talk about instantaneous acceleration, what do you think this would mean? Acceleration is also known as the change of velocity over time. So it's pretty much the exact same thing, but instead it is dv by dt. That means the change in velocity with respect to time. The change in velocity with respect to time is general acceleration with respect to time. This is pretty much just acceleration. But instantaneous means that exact moment, that exact d moment, that small change, because there's a very small change. That is where we have dv by dt. So yeah, so this is what instantaneous acceleration means. So what we basically just have to understand is, which is very simple, is that through a question now you're going to understand how we really use these terms. So let's talk about a question real quick. So I don't know if I did this in the last class or not, but if I have displacement which is given as t square minus 3t plus 2, I want to find my velocity with respect to time and my acceleration with respect to time. Now, what do we know what velocity is? Velocity is nothing but the differentiation of this, right? Differentiation of this with respect to time. So d by dx of dt will be equal to velocity, which will be equal to differentiation of this whole equation. Now, we will be doing normal differentiation here because we are differentiating time with respect to time, right? So it is just normal differentiation. So we get 2t minus 3, and a constant always is 0. So we get our velocity as 2t minus 3. Now you're going to see something incredibly interesting now. Now that we know our velocity as 2t minus 3, can we find our acceleration? So I want you guys to take a minute and try and find the acceleration. So again, the acceleration will be the differentiation of velocity, right? So you have to immediately understand that if an equation of x is given, all you have to do is differentiate velocity and then differentiate velocity to get acceleration. So that means my acceleration will be equal to dv by dt, which will be equal to differentiation of this equation, which will be 2 minus 0. So my acceleration is equal to 2. So what does this mean? My acceleration is a constant in this equation. Now this need not always happen, because in other situations we might get acceleration in terms of t. So then obviously it's not a constant. But here you can see we are getting acceleration as some k constant, which is 2 in this case. So this was pretty interesting. So let's do another question where my acceleration is not going to be constant. So let's start in a slightly different way. So I have my acceleration as 2t, my acceleration as 12t. No, sorry, fine. We won't start with that because we'll talk about that in a moment. But my x is given as 2t cube. Sorry if I'm looking a lot in that direction. That's when my book is 2t square cube minus 8t square plus 4t minus 2. So how do we go about this problem? So x, if we differentiate it, dv by dt is equal to acceleration, dx by dt which will be equal to differentiation of this whole cube. So we'll get 6t square minus what? 8 into 2, 16t plus 4, which is equal to velocity. So now we have velocity is equal to 6t square minus 16t plus 4. Now if you want to find our acceleration will be dv by dt. As we learned from our last question, it's a very simple, it's a straightforward question. So I'm just going about it pretty quickly. So this will become 12t minus 16t. Now the thing is, what if instead of giving my x here, let's forget about my x. What if instead of giving my x here, I am given only my acceleration. I am given acceleration is equal to 12t minus 16t. 12t minus 16, sorry guys, this was just 16. 12t minus 16. Now what do I do? What do I do in this situation where I only have 12t minus 16? How am I going to find my velocity and displacement? Now what do you guys know about the opposite of differentiation? So we know if we differentiate x, we will get v. Now is there any possibility of doing a function of v which is the exact opposite of differentiation to get x? It's kind of like reversing the problem. It's like reversing it. Isn't that what integration is? Now integration is pretty much the opposite. Integration is pretty much the opposite of differentiation. Now theoretically I'm giving this as an easy way, but obviously it actually isn't exactly the opposite, but just to make our lives easier. So this is how we would solve a problem where acceleration is given. So for example acceleration is given as 3t square minus 4t cube at, now you'll be wondering what is this at t is equal to 0, v is equal to 0, and at t is equal to 1 second, x is equal to 0. Now I want you guys to try this by implementing integration and try and get this answer. So how would we get it in that way? We would get acceleration is equal to, if we have to differentiate this, what do you think would happen? Integrate this. So integration, we're going to be doing integration. We're not going to be using the limits in this case. We're going to be adding a constant. Now why are we going to be adding a constant? I'll tell you just in a second. So obviously this would be 3t cubed by 3 minus 4t to the power 4 by 4. I hope everyone knows integration, because yeah, so this is what we get. So that means my acceleration will be equal to t, this will be v. My velocity will be t cube minus t to the power 4. Right? T cube minus t to the power 4 is going to be my velocity. So plus c, obviously. Now why are we using this instead of the limits? Now you tell me, are my limits given anywhere? My limits are not given anywhere, so I have to add this constant c. But what I do know, at a certain case where velocity is 0, t is also 0. So I can substitute it in this equation right here, and I'll get the value of my constant c. Now my constant c's value will never change. So for example here, 0 minus 0 plus c. That means my c constant is 0. Now that means for any situation wherever t is 1 second, 2 seconds, 3 seconds, 4 seconds, or 72 seconds, my velocity will always be, my constant will always be 0 in this case. So that means I would just get v is equal to t cube minus t to the power 4. Now I have to integrate this once again. I have to integrate this once again to get the answer, right? So if I have to integrate this again, I would get x is equal to t to the power 4 by 4 minus t to the power 3 by, no, t to the power 5 by 5. I'm going to rub this off, plus again my constant c. So now you tell me here, there's a slight difference. Here they're telling me at time is equal to 1 second, x is equal to 0. So that means here I just have to substitute x is equal to 0. And I have to substitute 1 by 4 minus 1 by 5. Obviously 1 to the power 4 is 1 and 1 to the power 5 is 1. So I would get 1 by 4 minus 1 by 5, which would be nothing but 5 minus 4, 1 by 20. So this is 1 by 20 plus c, sorry about that, plus c, I forgot the c right here, is equal to 0. That means I can write c is equal to minus 1 by 20, right guys? because C will go to the LHS side and this will be on the RHS side, then you transfer the minus as well. My C will be minus 120. So I can finally write x is equal to t to the power 4 by 4 plus minus t to the power 5 by 5 minus 1 by 20. Minus 1 by 20. So I hope this makes sense for you guys. And yeah, so in the next video, we're going to be doing slightly different problems. Obviously, these problems were pretty intuitive. So the main issue here is integration and differentiation. So obviously, we will be coming to constant acceleration slowly. But if we start with this now, this topic seems a lot easier if you start with this first. Anyways, I hope you guys enjoyed this video, and I'll catch you guys in the next one.